Let's look at final exam question number 53 in Trigonometry Demystified, 2nd edition. Please refer to page 378. When we say that the cross product operation is anti-commutative, we mean that for any two vectors r and s in 3 space, one of the following equations holds true. Which one? And then we have A, B, C, D, and E. Now in the book, vectors are indicated by boldface, lowercase letters in most cases. But here on the beige board, I find it very difficult to make boldface distinguishable from ordinary writing. So here's an alternative notation for vectors. A half arrow, that's vector R, that's vector S. Once in a while they'll use a full arrow. Same thing. What does the anti-commutative principle mean? Well, as you may recall from your algebra courses, just ordinary arithmetic and algebra, the commutative principle for any two numbers or quantities, let's say x and y, if we have an operation, let's use the at sign for the operation. If the operation at is commutative, it means we can switch the order of the variables or numbers or quantities or whatever they are and always get the same result. Multiplication is commutative. Addition is commutative. Subtraction in general is not commutative. Division in general is not commutative. But what does anti-commutative mean? That doesn't mean the same thing as not commutative. Anti-commutative means that if you switch the order like this, you get the negative of the result. So, for vectors r and s, the cross product is anti-commutative, which means that the vector r cross s equals the negative of the vector s cross r. And by negative, we mean in the case of a vector that it has the same magnitude but the opposite direction. The same length, the same actual length, but it points in exactly the opposite direction. The correct choice here in this question, therefore, is choice B. That's what choice B in fact says, and that is what anti-commutative means.